This video is going to go through a couple of example gels and how you might read them, because this is way more likely the questions you're going to be asked versus just how does it work. So let's have a look at this first gel. This is an actual photograph of a gel, and you can see that it's not really clear. It's quite hard. You can see that some of those bands blend, but you can definitely see bands. You'll also notice that in this column here, in column number 1 and column number 18, they look the same, and that's on purpose. That one I'll go into in a bit more detail in the next video, but they are DNA ladders. So when I said you could get a DNA fingerprint from someone, this is what I'm talking about. This banding pattern is infinite in differences. So you can see that different lines, no two wells look the same. So even though number 2 here looks similar to number 10, if you were to confirm them next to each other, you'd see that maybe the lines and the bands didn't completely line up. So every individual, when you run your DNA through gel electrophoresis, so long as you've used the same restriction digest, it should come up looking differently because of your base sequence differences. Here are another 2 examples of gels that have been run. Now what you could do is you can use these known quantities in the first one here to measure against. So you can see this band that's present in gel B is all present at about 480. So you would presume that they are 480 base pairs long, those fragments. These fragments down here, you can see this is 66. So this is further down the gel. So further down the gel means that it moves faster because they each had 20 minutes or 30 minutes. It moves faster, and that means that it is a smaller fragment. The other thing that you can annotate on always on your gels, particularly if they've told you it's to do with DNA, is I always like to annotate that this end is the negative terminal and this end is the positive terminal. This is a bit more of a problem-solving version. It's obviously an illustration. It's not a photograph. So this is a photograph of a gel. This is an illustration of a gel, and it's using it to solve a crime. It's pretty straightforward once you have a look at it. Here is the blood stain that was obviously left at the crime scene, and then you just literally go through and match them up. You can see that Bob, John and Lisa all have those 2 bands here. This 3rd band though is only present in John. All right, so I'm automatically going, okay, John's got the DNA that's there. Let's just double check it. Well, that's a bit close. That's an interesting band. It's in all of them. Sorry, that one, that one, that one, that one, that one. So you can see the only person that matches all of the bands is going to be John. And so therefore you would presume that the blood stain was that of John. And this is the different DNA fingerprints between those individuals. So there's just a couple of examples. Then last video that I'm going to do on this theory bit is going to be ladders, and then we'll do a few questions.